we're going to be doing the AMC 10A 2016. So let's begin. What is the value of, oh, that's easy. That's 11 times 10 minus 10. So just 100. So what value of x is 10 to the x, alright, and 100 to the 2x, that's basically 10 to the 4x, equals 1000, which is 10 to the 3 to the 5, so that's basically 10 to the 15. So we have 10 to the 5x equals 10 to the 53. Okay, so for every $1 Ben spent on bagels, David only paid 75 cents, or spent 25 cents less. Ben paid $12.50 more than David. How much did they spend in the bagel shop or the bagel store together? So, if he saved $12.50, what's $12.50 divided by point?
Always solve at the edge of the blackboard so that the board camera can come on them. At the edge of the blackboard means here.
Okay. Thank you. Well, that's like dividing 125 by 2.5. It's just 50. So that means they probably bought 50 bagels or so. So that means that in the bagel shop together, they spent 50 times 1.75. I don't know how much that is, but we'll find out soon. Ba-da-ba-da-ba-da-ba. So $87.50. That's a hefty amount. You're spending $88 at the bagel shop. Remainder can be defined for all real numbers x and y. Y is not equal to 0 by rem x comma y equals x minus y floor x over y. What is the value of rem? 3 over 8 comma minus 2 over 5. Can't you just calculate that computationally? It's just 3 over 8 minus negative 2 over 5 times the floor of 3 over 8 times minus 5 over 2. It's 3 over 8 over minus 2 over 5. Then we flip it around with the a over b over c over d rule. So then, you get 3 over 8 plus 2 over 5 times floor of negative 15 over 16. Now, the greatest integer less than or equal to this one is negative 1. So we're going to say it's 3 over 8 minus 2 over 5, which is 15 over 40 minus 16 over 40, so negative 1 over 40. A rectangular box has integer side lengths in the ratio 1, 3, 4. Which of the following could be the volume of the box? So if the side length for the smallest side is x, then the second smallest side is 3x, and the biggest side is 4x. So multiplying those all together, that gives us 12x cubed. So it's got to be a multiple of 12. So that leaves 48, 96, and 144. And then it's also going to be divisible by 12 to get a cube. 144 over 12 is 12. That doesn't work. 96 over 12 is 8, which is 2 cubed. And 48 over 12 is 4, which is not a cube. So 96 is the only possible answer. Ximena, I don't know who names their child that, list the whole numbers 1 through 10 once. That might be a little insulting, actually. I'm sorry. To all of those named Ximena out there, have a pretty unique name. 1 through 30 once. Emilio copies Ximena's numbers, replacing each occurrence of the digit 2 by the digit 1. Ximena adds her numbers, and Emilio adds his. How much larger is Ximena's sum than Emilio's?
Maybe you're doing 2016?
Yes. So all the numbers 1 through 30 is 15 times 31. Oh, you'd probably solve it at the end, like he said. So 15 times 31. 15 times 30 is 225. 15 times... Wait. No, 15 times 30 is 450. So plus 15 is 465. And that's the sum of all Ximena's numbers. Emilio will replace each occurrence of the digit 2 by the digit 1. Well, let's see. How many numbers contain the digit 2? There's 2, 12, and 22. Oh, yeah, no. Every number from 21 to 30. Or, I think it's 3 inclusive. So, 21, 22, all the way to 29. So, all of these two are going to get subtracted by 1, so that's a -2 loss overall. These are 9, and they're each going to be subtracted by 10. Wait. Oh, but 22 is going to actually get subtracted by 1 more. So it's not just -90, but -91. So it's going to be -93. Huh, really? D, 103. Oh, 20. Oh, yeah. Forgot about 20. That 2 raises it to -103. So it's D. The mean, median, and mode of the values 60, 140, 50, 290 are all equal to x. What is the value of x? First of all, 75 just does not make sense because it's literally the mode. It has to be in the set more than once. Secondly, the mean and median. So let's see, 40, 50.
The problem that you solve always should be in the middle.
Okay. 60, 90, 100. And x is the median of this. So if we place x somewhere here, it's going to be the median. So it could be like this. Yeah, where it's the average of this in 60. Well, if the mean is equal to x, if the median is equal to x, then that means that the average of these two is equal to x. So x is just 60. Okay, does that work? I guess, I hope. What's 40 plus 50? 90. 60 plus 60 is 120. 90 plus 100 is 190 over 6 values. It's supposedly equal to 60. So 280 plus 120, 280, 6 is 60. So 400 equals 360. I smell bulls. So let's see. Where did we make a wrong turn? 40 plus 50 is 90. 90 plus 60 is 150. 150 plus 90 is 240. So 340 in total. Plus x divided by 6. And this is equal to x, apparently. So 340 plus x is 6x. 340 is 5x. So x is 68. Oh, that said, oh no. I was missing a part. Oh gosh, okay. We're not going to talk about that. There are actually 7 values. Oops. 540 plus x over 7. Okay, so 540 is, so x is 90. X is 90, D. Okay. Trickster Rabbit agrees with Foolish Fox to double Fox's money. Okay, as long as Fox pays 40 coins in total to Rabbit. Okay. Payment is made after the doubling. Fox is excited about his good fortune till he discovers that all the money is gone. Okay, so let's say he had X coins at the beginning. So X coins at the beginning, then Trickster Rabbit agrees with him to make it 2x, and then he has to pay it as 2x minus 40. So the next day, he comes around with 2x minus 40 coins. He doubles it for 4x minus 80, then pays the fee again to get 4x minus 120. And then, finally, he doubles it again to get 8x minus 240 and pays the fee. But oops, this is equal to 0. So 8x must be equal to 280. So 4x must be equal to 140. So x must be equal to 35. Poor Fox had 35 coins before he got robbed. He went from 35 coins to 70 coins to 30 coins. I don't know how he didn't notice that. And he went from 30 coins to 60 coins to 20 coins. I don't know how he didn't notice that. Then he went from 40 coins to 0 coins. My god, this Fox is an idiot, bro. Freaking idiot. Okay, so let's see. A triangular array. 2016 coins out of 1 coin. Okay. So isn't it just a triangular? Okay, so apparently n times n plus 1 is equal to 4038. So n squared plus n minus 4038 is 0. This is definitely not the best way to solve this. So 156. What the hell? Minus 1 plus minus the square root of 16153 over 2. What's 41 squared? 1681. Wait, no, this is 16,000. Oh, shootity, tootity. Okay. Well, I guess this is in a league of like 130 squared or so, because that's 16900. What's 129 squared? 9 times 9 is 81. 18, 26. 11. 2 times 9 is 18. 2 times 2 is 4, 5. Boo body, you better die. You better body. 16, 2, 6. 16641. Body, 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 body. As far as I know, there's no perfect square that ends in 3. Body, 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 roll. Body, 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 body. What's the what's similar to the square root of 4038? I'd say 60, maybe. So what's 60 times 61? Well, no. 64 times 65, I'll say. The 64 times 64 is 4096. So 4096 plus another 64 is 4100 plus 60, which is 4160. Which does surpass our limit. So 63 times 64 it is, which is 4096 minus 64 to land us in the realm of 4032, just under our limit. Body. And then, since we have 4032, then the nth row. But that's not exactly 4030. Wait! Oh god. Well, 4038? Oh no, that's 2019 times 2. Oh, I'm stupid. So yeah, 4032 thing matches perfectly. 63 times 64 it is. 9. Woo! Okay, a rug is made with... Okay, so we have an arithmetic regression here. What I'm going to do first here is I'm going to... Let's see. So 1 foot wide, let's call this S. And then this is S plus 2, this is S plus 4, this is 3, and this is 5. So the sequence goes S, 3S plus 6, 5S plus 20. So 5S plus 20 minus 3S minus 6 is equal to 2S plus 14. This has to be equal to the difference between 3S plus 6 and S, which is 2S plus 6. That doesn't make any sense. Oh, the areas of the 3 differently colored regions. So, okay. So S, then the second region is going to be 2S plus 6, because we subtract. Then the third region is going to be 5S plus 20 minus 3S plus 6, which is 2S plus 14. So S plus 6 better be equal to 8. So S is just 2, which forms the arithmetic sequence 2, then 10, and finally 18. Yup, okay, 2. Wait. Yeah, 2. B. Wait. Let me just... Wait, oh my god, bro. What did I do this time? Hello? Hello? This thing is unresponsive. How many... Oh, okay, I guess I just entered it wrong. 7. Okay. So 9 should be D. I don't know why I answered C over there. And 10 should be B. Okay. 11. Find the area of the shaded region. I'm just going to assume those two are the same area. And I'm going to find the area of one of those necktie-looking things. So if I do this, this total length is 7 over 2. Meanwhile, this length is 1. So this length is 5 over 2. And this length has to be 2. This length is going to be, well, this is 1, so this is 1, and this is 7 over 2. So the area of this one is 7 over 4. The area of this one is 5 over 2, also known as 10 over 4. So 17 over 4 is the total area of these two triangles, and the total area of the rectangle is just 7. So 28 minus 17 is 11. So 11 over 4 times 2 is 11 over 2. 11 over 2. How am I gonna make that? That's 5.5. Mama. Okay, I do not know why that happened. Is there? Oh, wait a second. The total length of this is 5. Oh, bro, and the total length of this is 8. Oh, bro, I'm such a dummy. Thank God they didn't put a choice for 5.5. Otherwise, I would have been caught lacking. Wow. So the area of this is 3, so 12 over 4. The area of the other one is 15 over 4. And the area of the total rectangle is 4 times 5 over 2, which is 10. 40 over 4 minus 27 over 4. 13 over 4, which is 6 1/4. Wait, no, it's not. Oh, we're supposed to multiply by 2. It's 13 over 2, which is 6.5. Okay. Okay. Probability P that. Well, it's either odd times odd times odd, or there's really no alternative. You multiply anything by an even number, it's going to become even, no shot. So, probability is going to be 20. Well, how many odd integers are there? I'm going to just assume it's 1008. Times 1007, because they have to be distinct, over 2015. And 1006 over 2014. So this is 1/2. This is slightly less than 1/2. And this is slightly less than 1/2. So that means the whole thing is less than 1/8. So it should be A. Okay, 5 friends sat in a ouch, that hurt. Movie theater in a row containing 5 seats, numbered 1 to 5 from left to right. 1, 2, 3, 4, 5. Okay. Bea had moved 2 seats to the right. Ceci had moved 1 seat to the left. D and Edie had switched seats. Alright. So first of all, Bea can't be in 4 or 5, obviously. So let's assume she's in 3. So this is going to be our before scenario. And this is going to be after. So before and after. So if Bea was in seat 3 before, she would be in seat 5 after. Then if Ceci had moved 1 seat to the left, he can't have been in seat 1. Let's see. He and Edie had switched seats. Okay. So I've been thinking about it now, and actually, the only possible arrangement is for Ceci to sit here. You know why? Because if D and Edie go here, then uh, and then Ceci goes here because she obviously can't go to seat 1. Then she's going to just move into D's spot after, so that can't work. So then, if they go here and here, D and Edie, and Ceci goes here, that's the only one that works. Because meanwhile, if they go here and here, D and Edie, Ceci can't go here because Edie's gonna be there. Oh, but Ceci could still be here. So no matter what, I think Ceci could be in seat 4. So then she would move to seat 3. And then D and Edie have to be in one of the spots that isn't taken in either of them. Oh, leaving an end seat for Ada. No. Leaving an end seat for Ada. So Ada must be here. So that means D and Edie weren't here before. But Ceci was there. So D can't have been there. So this arrangement does not work for Ceci. Let's say Ceci is in seat 5. Then she moves to seat 4. And let's see. That means that Ada has to be in seat 1 over here. But that doesn't work for D and Edie. So then, let's say she goes to seat 2. And then she'd be in seat 1 at the end, but we need an edge seat for Ada. So maybe our initial assumption was wrong. Let's say Baez was in seat 2 instead. Then she would later be in seat 4. Now let's test out where Ceci could be. Ceci cannot be in an edge seat at the end because she was one. Well, yeah, she can't be in an edge seat at the end because Baez already taken up spot 2. Let's say Ceci is in spot 3. Then she moved to spot 2. D and Edie had switched seats, leaving an end seat for Ada. They can't have switched seats without being in an end seat, which would leave number 3 for Ada. So no, this arrangement does not work either. What about 4? Then Ceci would move to seat 3. Can't have been in seat 5 if Bale was in seat 2 because they would move to the same spot. And this should leave a seat for D and Edie, but once again, D and Edie must be sitting in these two, the only ones unoccupied in both scenarios, which would leave seat 2 for Ada, which is not an edge seat. Okay. I don't think there's any other possible conclusion. So that means Bea must be sitting in seat 1 because we've cleared her of seat 2 and 3, and we know that it isn't possible for her to sit in seat 4 and 5. So that means Bea must be in seat 3. And then after. And then where did Ceci go? Ceci can't have been in seat 2. Well, he could have been. What would happen if Ceci was in seat 2? Well, then Ceci would move to seat 1, but the only ones that aren't occupied would be 4 and the other edge seat, which should be reserved for Ada. So now let's say Ceci goes to seat 3. Then that means that Ceci will be at seat 2 in the end. So then D and Edie do have these 2 spots to sit in. And that leaves Ada to sit in seat 1. So that means he must have been sitting in seat 2 beforehand. Woo. Oh, finally that's over with. 14. How many ways are there to, dear God? Right, 2016 is the sum of 2s and 3s in one order. That's not good. That is not good. Good. I hear something? Um. Oh wow. Well, when we have 1008 times 2 and 0 times 3, the next possible way to do it would be, I think, 1005 times 2 plus 2 times 3. Yeah, that's the next possible way to do it. Yeah. So that means we'll be making jumps of 3 in this department and jumps of 2 in this department. And at the end, we have 672. We're probably dividing that by 2 will be our answer. And then that leaves us with the question of, is it 336 or 337? Am I forgetting to count some sort of end case? Maybe I am, which is why I'm going to do it with a smaller number, such as 48. There are only a few ways to write it. It could be 2 times 24 plus 3 times 0. It could be 2 times... Now, theoretically, because we have 24 here, well, no, theoretically, because we're making jumps of 2 in this department, and the end is 3 times 16, we should be there after 8 combinations. But we'll have to wait and see. Is it 8 or 9? So 2 times 21 plus 3 times 2, 2 times 18 plus 3 times 4, 2 times 15 plus 3 times 6, 2 times 12 plus 3 times 8, 2 times 9 plus 3 times 10, 2 times 6 plus 3 times 12, 2 times 3 plus 3 times 14, and 2 times 0 plus 3 times 16. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. That means this to be 337 possibilities. See. 7 cookies of radius 1 inch are cut from a circle of cookie dough. Neighboring cookies are tangent, and all except the center cookies are tangent to the edge of the dough. The leftover scrap is reshaped to form another cookie of the same thickness. What is the radius in inches of the scrap cookie? Okay, so let's see. Whatever's left over is, let's see. The radius of this fella is 3 inches. That means its area was 9 pi minus 7 pi from all of these fellas. So that means that the remaining area would be 2 pi. So the radius would be rad 2. A triangle with those vertices is reflected around the x-axis. Oh no. Okay, let's see. 0, 2. So 0, 2, 2 minus 2 minus 2 minus 3, 2. Oh, minus 3 and minus 3, 0. Right triangle is reflected about the x-axis. There we go. And then rotated counterclockwise about the origin by 90 degrees. I think that means that we'll be drawing minus 3 here, and we'll have a triangle that looks like this. Would reflection about y equals x work? Yeah, probably. I can see it. Yeah, and reflection about the y-axis would just put it here. I'm gonna say reflection about the line y equals x. There's no rotation is gonna change its mirroring. So D. We still haven't gotten an E. Let n be a positive multiple of 5. One red ball and n green balls are arranged in a line in random order. Let Pn be the probability that at least 3/5 of the green balls are on the same side of the red ball. Observe that P of 5 is 1 and P of n approaches 4/5 as n grows large. What is the sum of the digits of the least value of n such that P of n is less than 321 over 400? Well, what we're going to do here is I'm going to take so if we have 5 balls, you know I love my balls, we have 6 spots. You can think of it as there being a spot right to the left of every single ball, but wait a second, there's an extra spot to the right of this one. That's why there's one more than the amount of balls. Balls! Anyway, and that makes 6 spots here. So let P of n be the probability that at least 3/5 of the green balls. So P of 5 is obviously 1. What about P of 10 balls? 5, 8, 9, 10. 3, 4, 5, 6, 7, 8, 9, 10, 11. 3/5 of the green balls, so that's 6 of the green balls. So that means anywhere to this side is safe. And anywhere to this side is safe. So this one single spot is a danger zone. So here the chance is obviously 10 out of 11. Let's see. Okay, let's see. You have n voltage. Can I find a pattern? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and that's 16 spots. So 9 to one side and 9 to the other. So here you want to have 6 balls to either side of you, and that doesn't work for one spot in between 2 balls. Here you want to have 9 balls on either side of you, And obviously that doesn't work for 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's the safe boundary for 1. 6, 7, 8, 9. Here's the safe boundary for another. So this is the danger zone. 3 spots. I'm not doing this, not today, boys. Okay, each vertex of a cube. Okay, 4 numbers on the vertices. Okay, so let's say we have our cube here, right? So let's see. A, B, C, D. A, B, C, D, E, F, G, H. So one of them is just going to be E plus F plus G plus H. Another one is going to be B plus D plus H plus A. Another one is going to be A plus B plus C plus D. Another one is going to be B plus C plus F plus G. Another one is going to be C plus D plus E plus F. And the last one is going to be A plus D plus C plus H plus E. That means A plus D is equal to F plus G. Yeah, that's some information. A plus B plus D plus H. So A plus B is E plus F. There's no combination of B and D other than the one on, yeah, of course, they're opposite. Oh no. So let's see, C plus F. So B plus G is equal to D plus E. C, D, E, F, A, D, H, E. E plus D plus E. So C plus F is A plus H. And where else does H appear? Oh yeah. A plus H has to be equal to C plus F. Oh, never mind. We already did that one. So yeah, these are the 4 tenets, the 4 equations. Now, if I can combine them all into one, that would be great. E plus F minus B plus D equals F plus G. So E minus B plus D equals G. B is D plus E minus G. So yeah, obviously that makes sense. I make very bad. Decisions. Oh, wait a second. That means that A equals C. Wait, no, but that can't be possible. Okay, A plus D is, okay, so let's get all the yada yada over with. That's the 4 equations. Yes. Okay, so let's see. I'm not doing this one either. Time. Okay, point. Okay, trisection. Oh my gosh. A, B, C, D. Point. Okay, E between B and C. B, C. Okay, so these perfectly trisect this. Wait, what? So 1, 1, 1, okay. Segments AE and AF intersect BD. This is just a coordinate passing problem. When you give equations to all of these lines, you can just instantly find this out. Coordinate geometry is exactly what I'm going to do. Let D be 0, 0. A is now 0, 3. B is now 6, 3. And C is now 6, 0. That means that when we're connecting to E, we're connecting to 6, 2. When we're connecting to F, we're connecting to 6, 1. So AF can be written as the function AF and AE. Well, this slope is negative 1, 6. So y equals minus 1 over 6x plus 3. Meanwhile, this one goes down 2 and 6. Y equals minus 1 over 3x plus 3. And that line is just going to be y equals half x. 3 over 6x, 4 over 6x, 2 over 3x, 9 over 2. So that's when AE intersects BD, also known as Q. 9 over 2, comma. Well, this is on half x, so 9 over 4. Meanwhile, Q's coordinates are going to be, let's see, y equal 1 half x equals minus 1 over 3x plus 3. So 3 over 6x equals minus 2 over 6x plus 3. So 5 over 6x equals 3. So x is 18 over 5. So 18 over 5, 9 over 5. So let's see. QD can be written as 1 over 5 times the square root of 18 squared plus 9 squared. So 1 over 5 times 9 times the square root of 2 squared plus 1. So 9 root 5 over 5. Okay, so if this is 9 root 5 over 5, what is PQ? Marabo. What is 9 over 4 minus 9 over 5? It's 45 minus 36 over 20. 9/20. So 9 over 20, 18 over 5, and then 18 over 4 comes 18 over 20. Bada boom. This is just 9 root 5 over 20 now, isn't it? And then this length right here is going to be bada boom. 18 over 4 and 9 over 4. So it's going to be 9 over 4 root 5. So 9 root 5 over 4. So it's going to be 9 root 5 over 5 to 9 root 4 over 20, 9 root 5 over 20 to 9 root 4 over 4. Or 9 root 5 over 4. Bada boom. BP. Oh, it's backwards. Okay. What if 1 over 4 to 1 over 20 to 1 over 5. Multiplying this by 20, we get 5 to 1 to 4. So, let's see. 10. What? I calculated everything right, no? BP, yeah, that's 9 root 5 over 4. To PQ, yep, that's 9 root 5 over 20. To QD, which is 9 root 5 over 5. I'll just pick B. Oh my gosh. Okay. Some particular value of n. Okay. What is n? Wow. We can't use the binomial theorem on this. Well, I mean, technically we can. Because we could count a plus b plus c and d plus 1 as our two terms. Then we get a plus b plus c to the n plus... I'd rather not, honestly. I would not like to do this. I'm so tired. On the same side, line L. So let's see. This is P root P. Excuse me. Q. And R. It's the area of triangle PQR. The area is 0, dummy. Just a freaking straight line. I know this may be weird to you, but I'm checking the solution, and if it is not A, we'll be flabbergasted. What the hell? Okay, well, I haven't taken a look at the actual answer yet, but at least I know it's not A. Oh, it's because the tangents fall on different lines. Oh, shit. Yeah, like this one, it looks like this, but this one has a slightly smaller slope. That's killer. Like this one is 3. This one is 5. Wow. No, you thought I was gonna say a different word. Human rights, or like human suggestions. Root 8, so 2, 2. Why do I have to do this? Okay, let's call this 0, 0. This is minus 0 minus 1. And this is 2 root 2 minus 2. Root 24 is 2 root 6. So let's see. This is 2 root 2 plus 2 root 6, comma, negative 3. So the single is going to be 2 and 2 root 2 plus 2 root 6. What's the hypotenuse? Find out in the next episode of Suborno Does Stupid Things. Woo! 2 2 squared is 8. Square rooting that, we get 2 root 9 plus 2 12. Wait, I've been stuck on the solution page all this time? Why? Okay. What am I doing? I don't know. How am I supposed to simplify this? Someone tell me. This one just looks the most natural, so I'll pick it. I have no better options, nothing better to do. Actually, I did this one with Luke the other day, so I won't. So that means that 2016 diamond, this is the last question I'll actually actively try to do, is equal to 100, which is also equal to 2016. Wait, no. Oh, 2016 times 6. No. 2016 diamond 6 times x. Don't escape the institution. I'm not doing this anymore. I can't take it. I'm tired. I have so much work to do. I have way too 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 much. Bye.